This unit and next unit, the topic, both units is triangles. You thought you knew a bunch of, three sides, the angles add up to 180. You have no idea what's in store now. All right, so this unit and next unit, going to be talking about triangles. Here's what I want to do today. If I'm looking at a triangle and I know nothing about its angles, but I know something about all three sides, how do I name it? So naming a triangle just by looking at its sides. So if you know all three sides are congruent, anybody know what we call that? If all three sides are the same length, that's a what type of triangle? Equilateral. All right. So if all three sides are congruent, equilateral. You look at a triangle and only two sides are equal, and the third one is not equal to the other two. That is a isosceles triangle. Yep. Nice spelling word too, isosceles. Or I look at a triangle and none of the sides are the same length. That is nothing, huh? Oh boy. We got work to do, huh? Nothing? Scalene. If no sides are the same length. Scalene triangle. All right, well, what happens if I don't know anything about the sides, but I do know something about its angle measures? First thing, in a triangle, all the angles add up to what? 180. All right, all angles add up to 180. If all three angles are congruent, could you get away with calling it equilateral? Yeah, that's fine, because that means all the sides are equal. But also another name, if we know the angles are equal, equiangular. How about that one? Equiangular. And you just told me all angles add up to 180. So if they're all congruent, what's each angle measurement here? 60, 60, 60. Good. All right, next one. One angle's 105. Well, what about the other two? Doesn't matter. As long as one is bigger than 90, we can classify this as a obtuse triangle. Yes. I don't care about the other two angles. I recognize one angle's bigger than 90. That automatically makes that an obtuse triangle. All right, the next one, no big deal. We actually dealt with those a couple times last unit, and these are a right triangle. That's a right triangle. And the last one, I got 70, I got 30. We could find the other angle. What's the other angle measure then? I got 70, I got 30. Third one's got to be, if they all add up to 180, 80 degrees. So notice all three angles are less than 90. This would be acute triangle. All three angles less than 90. If you have one bigger than 90, we call it obtuse. Any issues naming the triangle? Today's going to be a short day of notes, I hope, anyway. We'll see. Anything? All right. Let's start naming triangles then. You're going to see some vocabulary terms we've talked about in the past. M is the midpoint of JL, so hopefully that tells you something. Tell me what triangle. All right, hey, first thing, let's get used to the notation here. Triangle JKM. A triangle is named by its three vertices. So can you identify where triangle JKM is on this diagram? JKM. I want to know what type of triangle that is. Is it equilateral, isosceles, or scalene? Well, hey, you can't tell me right now unless you know something about all three sides. And I only know that this side, KJ, is 0.75. That's the only side I know. We have to find more then. M is the midpoint of JL. Give me the length of JM and ML then. All right, JM and ML have to be how long each? Here we go. Let's go to the numbers 9. Each they have to be. M is the midpoint of JL. Half of what? Okay, go ahead. Whatever that is. Got to have it so I can figure out the length of JM. Okay, so JM is 0.75. ML is 0.75. We're all good on how we got there. M's the midpoint. I take half. All right. One side remains, which is KM. Look at your diagram. How can I find the length of KM and what is it? 4?
KM is the midpoint of JL and it's
Whoa. K. How can a line segment be a midpoint?
oh.
Look at the markings on the diagram.
KM is congruent to MM.
Okay, so KM has to be
0.75.
0.75 as well. Everyone's good there. That was given. Those two sides are equal. All right, now look at JKM. Look at all three sides. This has to be what type of triangle? 2?
Equilateral.
Why?
Because all three sides are congruent.
There we go. So here we go, everyone. Start using the notation 2, please. Triangle JKM is equilateral. Because all three sides congruent. Any issues, questions? All right, let's keep going. Number 2, I gave you an isosceles triangle, and I told you what sides are congruent. All right, I'm only doing this one for 2 reasons. One is just because they give you, do you see I gave you all 3 sides? That doesn't mean you need to use them. It's not mandatory that because I gave you all 3 sides of the triangle, you have to use them in the equation. Other thing, remember we talked about 180 degrees? What's that for? Sides or angles? Angles. Are these angles? The ones I gave you? No. So don't tell me all 3 added up equal 180. Come on now. Sides don't equal 180. It's only angles. So I'm going to ask somebody right now, come up with an equation to solve with x. You don't need to use all 3 sides. It's not mandatory. Give me an equation to set up that would solve for x here. It's isosceles, not equilateral. 5?
Would 4x plus 1 equal to 5x minus 6.5 work?
Yeah, it would work. Why? Because they're both congruent. Again, I don't need to use the 9x minus 1. Just because they give you all 3 sides, it's not mandatory. Go ahead and solve. We'll figure out what x is. When you have the value of x, let me know. 4, when you're ready. 1.5. I'm trying to break this habit in some of you. Just because you find x doesn't mean we're good to go. Move on to the next problem. Find the measures of the sides. So AC, BC, AB. What are the measures of the 3 sides? And we know because it's isosceles, hey, I should get 2 answers that are the same lengths. When you're ready, let me know those 3 sides. When you're ready. 11 here. 11 here. Nope. How about, yep, 5's here. When you're ready, 5.
7. Oh, A to C equals.
Just say AC.
1.
You're good.
AC
Yep.
equals 7.
Got it?
BC equals 7.
I hope so, right? Because they're congruent. And what about the AB?
It equals 12.5.
There you go. Hey. We're all good? All right, last one. This one brings me a lot of joy. If you're wondering why, because it's probably going to bring you a lot of misery. That's why it brings me a lot of joy. First thing, graph it. When you are graphing, please label the points with the corresponding letter. Just want to make sure we graph it correctly. Draw in the triangle after as well. Just don't graph the points and let it be. Draw in the triangle. Again, make sure your points, your vertices are on there. D, E, F. Nice job, ladies. What happened here, boss? What, -5? Okay, that's fine. 2, 1, -8.
Oh, -8. Okay.
Yep. You're good. You're good. Fix it up. Fix it up.
How did you do that? I have no idea. I think. Yeah, you're right.
Okay, here we go. Classify it by its sides, meaning, okay, is this going to be equilateral, isosceles, or scalene? And we're not just going to look at this and take a guess and move on. How are we going to make sure if it's equilateral, isosceles, or scalene? I need to know all three side lengths, right? You need to know all three side lengths. How am I going to do that? How am I going to figure out how long DE is, how long DF is? We're going to dig up an old reliable method from Unit 1. Anna? Oh, or maybe not, sorry.
I was gonna say slope.
Well, slope won't do it for me. All right, slope won't, well, it'll almost get me there, but I need to actually know the lengths of the lines, not if they're parallel or perpendicular. What do you got here? Distance formula. Yeah, come on, anybody? First period Monday. Distance formula. Yep, there you go. Yep, distance formula. Yep, good. I love the excitement. Let's review distance formula. I'll spot you D equals. What else you got for me? Come on, let's go, Spence.
Is it x1 plus 2 to the second?
Already off.
That's not.
It is minus.
It's x2 minus x1.
Okay, so x2 minus x1 squared.
And then y2 minus y1 minus y2. Sorry, it's plus y2 minus y1 to the second. And then you divide it by 2.
You're combining that with midpoint now. There's one huge thing I'm missing. Literally huge. Hi, Charlie.
The square root tool.
There you go. The old big square root over all this. Yes. Yes. So here's what I'm going to do. I'm going to do one of the sides with you, and then I'm going to let you do the other side in your group or by yourself, the other two sides. So here you go. Not class decision, your decision. 9, who's got 9? Elio, pick a side. What's that? D's not, I need a side. D's a vertice or a point. I got to find an actual, you got to put like DE, DF, right?
Yeah.
DE? Pick another one. Sorry. I don't like that one. I'll show you. I'll show you. What is it? FE it is. Great choice. FE. So let's find the length of FE. All right, FE. Big square root. Now I subtract the x's. Unlike slope, the order doesn't matter. You subtract it in. So give me the x coordinates of F and E, please, to subtract. 11. Nope. 7.
F is -8.
Yep. Minus
-2.
-2. -8 minus 2 plus. Now somebody give me the y coordinates of F and E. Here we go. 4. Y coordinates of F and E.
3.
Minus.
1.
Okay. Good job. Good job, both of you. All right, let's crunch away here. I want to remind you of some things with the distance formula. -8 minus 2, -10, right? Square it, what do I get? 100. Hey, remember this. After you're done squaring, none of these two numbers should ever be negative. Put it in parentheses in your calculator. All right, none of these numbers should ever be negative after you're done squaring. Plus, what am I going to get over here? 3 minus 2 all squared. That gives me 2 squared, 4. Everyone's good? Add them. Do not take the square root of each. Add them up. You get the square root of 104. All right, here you go. I don't want a decimal answer. Okay, I don't want a decimal answer. I believe we are in, I've been telling you all year long, and you guys have been proving me right with your scores here, an above average math class. So we are not, I am not looking for decimal answers. Simplest radical form. And I think we did this in unit 1 when we did distance formula. When you break down a radical, simplify it. So let's go through the steps again. I'll go through slowly. You break it down into, if you can, if you can, break it down into 2 radicals. Under one of the radicals goes a perfect square, the biggest perfect square that goes into 104 without any remainder or decimal. So let's review one more time. We did it in unit 1. What are perfect squares that you're going to test out? Anybody? Let's list them out. Perfect squares. Do we start with the first one probably you're going to test? Oh boy.
4.
2 squared, 4. 3 squared, 4 squared,
16.
5, 6, 7, 8, 9, and I'd be surprised if you went above that. So there are the perfect squares you're going to try out. So I will do this with you. You grab your calculator. I do 104 divided by that first perfect square, which is 4. Good. Oh, it went in. No remainder. All right, but I need the biggest one. I can't stop there and be satisfied. There might be a bigger one. So here I go real quick. 104 divided by 9. Is that going to work? Do you see what I mean by this one has a remainder, a decimal after? So 9 doesn't work. I keep trucking along. How about 16? Nope. I'm not even going to try 25. I know 25 won't work. How about 36? Nope. 49? Nope. 64 real quick. Okay, I don't think it's going to. So what was the only one that worked? 4. So now in that radical, I put 4. And what did we have to multiply 4 by? 26. So in simplest radical form, 104 breaks down into, what's the square root of 4? There's a reason why you pick a perfect square, to take the square root. Square root of 4? 2, just 2. And then the radical 26 comes into your answer. So there's FE. All right, I'm going to walk around and help you out with your group. You have to do the other 2 sides. And I'll warn you, hey, one of the sides cannot be broken down. You just leave it in the radical. And then the other side can be broken down. Okay, so one of the radicals can be broken down. The other one cannot be broken down. Go ahead. I'll come around, help you out, see how you're doing here. So find the other 2 sides of this triangle. All right, nice job, everyone here. DE came out to be the square root of 113. You cannot break that down. No perfect squares go into 113. And then DF came out to be the square root of 45, which could be broken down. That's broken down into the square root of 9. That's the biggest one that goes into 45. And 5. So you ended up with DF being 3 square root of 5. All right, let's take a look at the 3 sides. You got 3 square root of 5. You got 113. And you got 2 radical 26. All 3 side lengths are different. So we're going to say triangle DEF is, let's finish this. What type of triangle is it if all 3 sides are different? 1, Anna? Is scalene. Great job. Is scalene because, how'd you know that, Anna?
Because none of the sides are the same.
Yep, all 3 sides are different. All good? Any questions? All right, you guys see the bookwork? Please pay attention there. For number 43, leave your answer in simplest radical form like we did in class today. All right, so you can grab the textbook. And let's get trucking.